Alright, hello people watching this video. We're going to start with number 7 on the review. And then maybe add something to your yellow sheet, your yellow chart. So you guys might need that out as well. If you don't have that out, get your yellow sheet out. That's got all your formulas on it. Use the given data to find the minimum sample size. That means we're solving for what?
N.
N. That means we're solving for N. Okay? Used to estimate a population proportion. The error for population proportion is Z times the square root of, write this down, P hat, Q hat over N. And we're solving for N, which means we're working backwards. Okay?
Z is 2.575.
Okay. Real quick though, before I plug the numbers in, listen, shh. Before I plug the numbers in, I'm going to solve for N. Can we do that? And like rearrange this formula here? So what would you do first to solve for N? Divide by Z. Okay, so now I've got E over Z. Got it. He's gone. Now what? Square it. I'm going to take that thing and square it. I'm going to take this and square it. So this is gone now. Okay, so I've got E over Z squared equals P hat Q hat over N. Yeah? Okay, now what? I'm going to flip-flop these two spots. So N equals, here you go. Here's your formula for N. P hat, Q hat over E over Z squared. Okay? That's what we're going to use for our formula. P hat, Q hat. It's just taking that top equation for error and rearranging it. Okay? All right, now we need to know what P hat and Q hat are. And E and Z. So P hat, Q hat, E, Z. All right, Kelsey said Z for something. Z for 99% was how much? 2.575. They tell me I want an error of 0.028, which is already like in decimal format, right? Sometimes they'll give it to me as 2.8%. I've got to make it 0.028. What's P and Q?
0.5.
Yeah, if it says they're unknown, we assume them to be 0.5 and 0.5, okay? So all we have to do is figure out what N is. 0.5. Practice typing this into your calculator to see what you get. 0.028 over 2.575. Make sure you use parentheses correctly. Square that, see what you get. N again is our sample size, okay? So thinking like this should be like maybe 100 or 1,000 or, you know, however many.
2115.
2115? 2115.
5. It was 4 point something.
Wait, what the heck did you get?
Maybe
Yeah,
in my
0.4.
history.
Yeah.
0.4?
4.4.
How
Okay.
did I get 21.14357?
You didn't do a decimal right. Did you do 0.05 or something?
No.
Or did you not put a point?
Oh, I see.
Okay. Your decimal's in the wrong spot. Okay, 2114.4, which technically rounds down, but you always round up to the next person. 2115 people. That's how many I would have to survey in order to get a 2.8% error. Does that make sense? 2.8% error. I'd have to survey a little over 2,000 people. Got it? All right, here we go. Go to your yellow sheet and let's add that formula, that last formula under your yellow sheet. Do you guys have a little box on the right? Yeah? If you don't, just put this somewhere.
It's like Streff and golf practice. Oh, there's 2 clouds out today.
We're gonna cancel.
Okay, finding sample size. There you go.
Sounds like I wanna try.
Put this wherever in a box somewhere. Finding sample size. You don't need very much.
Use that one too.
Finding sample size. Shh. Finding sample size. Okay, we're taking this formula and we're rearranging it. So the very top formula, you could do this without writing this down, but like we just did.
Yeah, we're done.
Okay, so we're just gonna write it down. N equals just the formula that we just had. P hat Q hat goes on the top. On the bottom, it's like E over Z, that thing squared. Okay, now keep in mind that whole bottom needs to be squared before you divide it. Okay, that's how you find the sample size if you're given everything else. If P and Q are unknown, use 0.5.
We are not starting to.
Okay?
I'm going to do
Can I go
the
for
same.
Good? Yeah, sure.
'Cause I need to wash my hands.
I am
Go
not
fast.
your mother.
Okay. Good. Happy with that?
And I
You
do.
do have a mother.
There you go. There's the formula. All right. Let's go back to the review.
Oh, that's it?
Yep. That was it. That's all we're putting on the notes or on the thing. Okay. Here we go.
11.
We are on 11. Let's figure out what we're trying to find. I'm gonna go to. It says a laboratory tested 82 chicken eggs. What's 82?
Chicken eggs.
Dude, that would be expensive.
N is 82. And found that the mean amount of cholesterol was 228. What is that? X bar 228. Okay. With a standard deviation, but that is the population standard deviation. So keep that in mind. It's not S. It is, in fact, sigma. Construct a 95% confidence interval for the true mean
Wow.
cholesterol content mu. What is mu?
Average.
Average. So we're doing mean, which means we are doing 7.2 stuff.
Yep.
So on your yellow sheet, 7.2
So
stuff.
we need the first one.
Okay, so we are ultimately trying to find this guy and this guy.
Okay. So.
All right, so we need to decide if we're going to use T or Z. Okay,
So
again,
we go.
T is n's less than or equal to 30,
Z.
What's
or
95
excuse me, less
again?
than 30.
What's 95?
Oh, we're going.
T, oh, wow. N is greater than or equal to 30. And this guy is this one and this guy is this one. So you're going to use T or Z?
Sigma.
You're going to use Z, and what is Z for 95%?
1.96.
1.96. Okay, so we need to find the error, which is
So we go-
Z times
1.96.
this guy over the square root of N.
19. No. Yeah. 19 over.
19.0 over
Of 82.
the square root of 82. That's your error.
1.96.
Times 19 over the square root of 82.
Over square root 82 equals 4.112.
2.
We'll just go 4.11. Okay, 2 decimal places, 4.11 is the error. What do I do with that?
So add
What's
and
the
subtract.
minus from X bar?
Which is 228. So we've got 232.11.
Bottom is 228.89.
What? What?
I got
223.89?
I wrote it wrong.
There you go.
223.
So I can assume, all right, let's do this one. 12. Use your own words to interpret the meaning of the confidence interval above. We're talking about the cholesterol level of chicken eggs. So start with We are.
95% confident.
We are
95% confident that, what?
if we surveyed all.
If we
chickens-
test all chicken eggs.
Why did I put survey?
I don't care. You can just say survey, whatever. If we test all chicken eggs,
Between
the what?
or the mean.
The mean what?
cholesterol
Cholesterol level
Would be
cholesterol.
would be between 223.89 mgs and 232.11 mg. That's a pretty small window because our error is rather small. 4.11. Why is our error so small?
Cause we got a big ass
Where's
I mean,
survey?
80
Lots of
82 is as a decent sized survey. Okay, whatever.
Don't look at that.
All right, good.
Greater than 5.
Okay.
All right, now we're moving into standard deviation stuff. I'm not going to do all these for you, but we'll do a couple of them together. This is asking for the chi-squared right value. Okay, if you need to see that bigger chi-squared right value. Okay, chi-squared right. They just want the chi-squared right value. They don't need the left one. We don't care. The sample size is 19. That means n is 19,
No.
and the confidence level is 99%. Okay, where does 19 fall into play?
That's we have to go one less.
Degrees of freedom is
18.
18. So go to the chi-squared chart. Chi-squared chart. Okay. Go to 18 and 99%.
34.805.
We want the right one. We want the right side one.
34.805.
34.805. Okay, make sure you know how to find
This
that.
one. It's on the back side.
Okay, they're just asking for the right value. We don't care about the left value.
Y'all do.
Okay.
34.805.
So you go to
18 degrees of freedom, 99%.
To the right, 99%.
99. I'm getting it. 7.0.
No.
Okay.
You gotta go
We'll
over
do
to
that
the
in a
next
minute.
99%.
Okay.
The right one.
The right side. There's two columns that are 99%. You want the right one.
Do you have the numbers written at the top?
You would need the left one and the right one, but we're only going to do the right one. Find the critical value.
How did you choose the
Do you have
right
these?
one?
Do you have your
They
percentage?
asked,
Okay, that's the
find the
percentage.
right one.
Oh, makes sense.
That's all you need. Okay, good? All right.
Let's do
14. 14.
Well,
Here
where's
you
the
go.
other 99?
All right, let's see what we're trying to figure out. These are the hardest thing on the test is going to be like, are we doing a mean? Are we doing a proportion? Are we doing a standard deviation? Which one are we doing, right?
Okay.
Do you need me? Sure. Sure. Ugh.